All right, so the goal of this video is to go over how to define variables in Python. We'll also look at some of the primitive types in Python that are defined just right out of the box in the language. Look at some comparison operators and a few other things to do with variables, but we'll go ahead and get started. I'm just going to very quickly, I have a blank Jupyter notebook open here. Let me zoom that in just a little bit. And I'm just going to print out the version. So I'm currently running Python 3.12.2. All right, so defining variables. So in a previous notebook, we looked at some basic mathematical operations that you can do with the Python language. And we saw expressions such as, 2 plus 2. We can run that. And again, in JupyterLab, I'm running those code cells by holding down Shift and hitting Enter. But we can run these expressions and we can return a result. But oftentimes when we're writing programs, what we need to essentially store some computation in some type of an object because, if we're writing an algorithm or doing something else, we might want to change the state or perform additional computations, manipulations, or mutations on that object throughout our program. So we need some way of storing a current state of computation in an object in Python, and we're going to do that with variables. All right, so the way that we would define a variable in Python, let me just get that back there. I'll just leave that and run in a new cell. So let's say that we want to have a variable to store an integer 2. What we can do is we can define a variable name with a string here. So I'm defining a variable name myvar, and I'm going to use a single equals and set that equal to, in our case, the integer 2. If I were to hit Shift and Enter, now, if I were to put this myvar in a different cell, hit Shift and Enter, we can see that it's actually pointing to what we assigned to it. So in this case, that integer 2. All right, so a few things that I just want to note at this point. So first off, we see that, this worked when we did myvar, but there are going to be some restrictions on how you can name variables in Python. In particular, let's say that we wanted to say, make a variable named 2var, right? And try to run that same code. So in this case, I'm trying to assign this, 2var equals 2. If we run that, we're going to get an error. So in Python, you've got to name variables with strings or characters. So the first character in your variable's name needs to be a character or an underscore. All right, so just to give you an example, if I were to say var2 equals 2, that works. That's okay because my first character is a V, right? So that is a alphabetic character. So we can see var2 works. But again, if we tried to do that 2var, as we saw above right here, that does not work. And then it's also allowed to start with an underscore. So if we did an underscore var is equal to 2, that is also going to work. So we can begin with either characters or, alphabetical characters or an underscore, and you can actually just use an underscore, right? So you'll actually see this in a lot of, different code samples. I'm going to use this later on in certain applications. And this is very common in Python if we want to make an assignment to, say, like a temporary variable. And we're just wanting to kind of, reuse that. So we can use that underscore kind of as a throwaway or a temporary variable. So if I were to print out what underscore is, now that's assigned to 2. So that is very common. All right, so one thing that you definitely want to be careful of when you're naming variables, in addition to, the way that you name them, is that Python has, some names that are reserved, right? So some things that are defining, certain operations within the core Python language. And if you're not careful when you're naming variables, you can actually overwrite those. So let's look at an example of this. All right, so notice I'm just going to say, let's say that we wanted to write a variable to capture this sum 2 plus 2. All right, now watch what happens. Let's say that we might think that, a good variable name would be the name sum. Okay, but watch what happens if I start typing sum, so SU. So right now I've only got SU, so it's being displayed with black text. Notice what happens as soon as I put the M on. So as soon as I put the M on, the text changes from black to green. And that's indicating something very important to you, or it should. And that is that Python recognizes that name. So when we're going from SU, which is black text, and as soon as I add that M, we see that Python recognizes that as, it's basically indicating, hey, I recognize this. This is a reserved name. Actually, if I were to hit Shift Enter, we can see that this is actually some type of a function. Okay, so this is one of the built-in functions that are just built into the Python language. It has a sum function. I'm going to show you in just a minute how you can get a list of all of those things that are kind of predefined in Python. But for now, let's just go down, continue this example out. So the way that this sum function works is you can pass it an iterable, and I know at this point you probably aren't familiar with what an iterable is, but in this case, just kind of follow the code. So I've got this container. This is actually a Python list, and that's indicated by those opening and closing square braces. And I've just got the objects 1, 2, and 3. Well, the way the sum function actually works is if I provided this, iterable and run that sum, it is going to sum up those integers or those numeric values within that iterable. So when we run sum of 1, 2, 3, it returns 6. All right. Well, remember, thinking back, I'd say, well, we want a variable to store this sum 2 plus 2. Well, what if we, even though Python, even though that's a reserved word, right, we clearly see right here when I run sum and I pass it this iterable, it returns the correct sum for the values in that iterable. Well, what if I were to reassign that to 2 plus 2? All right. So earlier when we ran sum, we saw it was a function. Now when I run sum, it's actually 4, okay? And if we're not careful, we might try to use later in our program that sum function in its originally defined manner. And when we run that now, it's going to give us an error. It's going to say, well, hey, this integer object is not callable. And why is that? Well, because right now, when we define sum is equal to 2 plus 2, it's storing an integer value in that variable, right? So in this case, we've actually overwritten the Python reserved function or the Python defined function, so we can't use that. So you got to be a little bit careful. So again, they're giving you visual cues here in this Jupyter notebook. We saw that text turn to green, so just be on the lookout for that. And if you want to see a list of all of the reserved words, you can actually use another reserved name, dir. This is a built-in function, and you can provide this string. So this is a double underscore, built-ins, and then ending with a double underscore. All right, so if I run this, you can see all of these names that Python knows right out of the box. So if we kind of look towards the top of this list, we see there's a lot of things that end with error, and these are like exceptions or errors that Python will return. And then if we go towards the bottom, we see things like that dir function that we just used. And we can also see things like the sum here. Okay. Another one that we're going to see here shortly is print. Okay, so print is a defined function in Python. So right now we've got this myvar. We had defined that earlier, but let's just say that we've got a variable, myvar. And in Jupyter, we kind of get used to the fact that whatever is on the last line of a cell in Jupyter Notebook, if you just are putting a variable here, if you run Shift Enter, it's going to print that out. But if you're writing a .py file, like a script or something like that, or if you need to do, print out the value of variables that are at different, maybe not on that last line, you can use that print function and you can print out the value of your variable. All right. So I'm going to go into a little bit more detail on the print function when we talk about strings in a later video, but just know that we have that print function available. All right, so we've been talking about variables. We talked a little bit about variable names, looked at some of the built-ins, some of the names that we don't want to use when we're defining variables. So now let's look at types. So I want to show you a few of the primitive types. This will not be all of the types, but this will be the ones that you kind of interact with a lot when you're working with single variables. And again, this isn't not going to be all-inclusive because we do have some container types that we'll look at in another video. But we'll just look at kind of a few of the core types in Python. All right, so in this case, and what I'm actually going to do after each one of these, I'm just going to use my var. I'm going to be overriding this, and I'm going to be printing out the type of my var as we assign it to different things. So in this case, I'm saying my var is equal to 2, and then I'm going to check the type, which notice that's another one of those built-in functions to Python. And I'm going to pass my var to that type. And we see that this is an integer type. So an int is an integer type. I'm just going to copy this down. All right, so now I'm going to do 2.0, which those two things are pretty much equivalent, right? They're both 2, but here when I indicate with that decimal point and I run that and get the type, so now we have defined a floating point number. All right, and in the video that I did on mathematical operations in Python, those very basic mathematical operations, we noticed that, you know, certain types of operations would give us an int or a float depending on the inputs, right? So this is, again, just kind of showing you that distinction. On these numerical types, we have an integer and a float. All right, also, a very common type that we deal with is our strings. So if I were to make hello as a variable and then do the type of my var, this is one of our string types. Okay. Now, a few other ones that I want to show that might be, you know, so we, you know, if we think about an integer, a float, or a float, you can think that's like a decimal point number, or a string. Those are very, very common types. Also, some additional ones that, you know, sometimes, you know, especially people that are new to programming, these are a little bit more novel in the fact that you don't really deal with these too much in if you're just working with Excel or something else. We have Boolean types. So we can define a variable as being a Boolean true. Now, again, notice that that's green bold right there. Right, so that's indicating, hey, Python is telling you, or JupyterLab in this case, I know what that is. That's one of those reserved names. And if I were to do the type of that, it's a Boolean type. All right, so we have true as a Boolean type, and we also have false as a Boolean type. Okay. And then finally, or at least the last one that I'm going to show in this video, is we have a none type. And this one's really, really interesting. So we can assign a variable equal to none, and if I do the type, well, that's a none type. All right, and the reason that I say this one's interesting is notice right here, so up to this point when we defined it to 2, we got back an int, we got a float, a string, a bool, and then finally here we get this none type. Well, watch what happens if I were to put int, that's a reserved word, right? So Python knows what an int is. I'm just going to hit Shift Enter. Right, so an int is an int, right? If we were to do a str for that string representation, right? Even a bool, right? So it's turning text to green, indicating it knows what it is. All right, if I were to put none type in, it doesn't know what that is. This will actually give me an error, right? So this one's a rather interesting case. So none is not necessarily a type. It's a very specific value. So that's maybe the better way to think about it. So it's not necessarily that none is a type, but it's a specific type of object that we can assign a variable to, and it's just an empty object. So we'll see this a lot when we get to like flow control or writing algorithms. We'll use none a lot to say, hey, maybe this variable hasn't been initialized to a value or something yet. All right, another thing that I want to talk about with variables, so we've looked at some of these common types, and let's actually show you programmatically. So, you know, sometimes when we're writing loops, we might want to check if a variable is a particular type, and this is going to kind of segue nicely into the next thing that I'm talking about with the typing system in Python. But let's just define a variable. Let's take this myvar, and let's redefine that to be hello. And then again, of course, we can print the type of that, and we know it's a string. Well, sometimes you might be writing a program and you're updating the value of a variable, and you want to check and make sure its type is a particular, you know, instance, if it's an int or a string. Then the easiest way to do that is to use this function that's built in called isInstance. Okay. And in this case, this is a built-in function. I'm going to show you one thing that is very helpful if you're working in Jupyter Notebooks. You'll see me do this a lot. But let's go ahead and look at it here. So I've got this function called isInstance. I've opened that left parenthesis. If I hold down Shift and hit tab, it's going to pull up the doc string for that function. And this is a thing that I really found to be very nice as I was learning Python, especially working with Jupyter Notebooks. You can get access to this doc string, which is like the help documentation for that function, kind of just built right in. All right. So what this is showing us is, hey, the signature is showing me, hey, well, I've got this function isInstance. It takes an object and then it takes in a class. Okay. So it takes in two arguments, object and class, and it returns whether an object is an instance of a class or a subclass thereof. Now, I'm not going to go too much into details here. Just wanted to show you how you can get that doc string up to get some information. So again, that was just, I'm holding down shift, hitting tab to get that up. And we'll talk a lot more about that when we talk about how we define functions and we'll really understand. But for now, when we're using functions, sometimes I might hold down shift and tab to get that additional help information up, but that's how I'm doing it. But what it does is, if I want to say, well, is my var an instance of type string, this will actually return true or false, a bool value, indicating whether that statement is true. So in this case, if I'm saying isInstance my var, is it a string type? It'll say, well, that's true. If I were to check and say, is that variable a float? That's going to return a false, right? So you can use that programmatically. Again, it's going to evaluate to a Boolean value, either true or false, and you can use that to control your programs. Right? The one that is a little bit weird, of course, is, remember, none. Even though we can make that assignment, we do get back a type. If I were to put type of my var when I've assigned it to none, it returns a type. You actually cannot check that because none type is not defined. Right? So if I were to say, well, isInstance my var none type, right? Well, as you can see, this text isn't changing colors like when we had float or string here. So this is going to give us an error. It says none type is not defined. All right. At this point, one thing that I want to kind of notice, and I've been doing this all along very subtly, just haven't drawn much attention to it. But this is actually a really, it's not a unique feature of Python because we do have this in some other languages, but it is one thing that really, I think, makes Python very, easy, or easier, I should say, for people that are new to programming to kind of get up and running with. So notice, like in this cell, we ran my var is equal to 2. And then in the very next cell, we said my var is equal to 2.0, which resulted in a float, whereas originally we had an integer. And then in the very next cell, we reassigned my var to a string equal to hello. So we're able to just change the type of a variable by assigning to it. And that's really interesting. So again, just to kind of demonstrate this, so if we do my var is equal to 2, and I'm just going to run a few things right here in this one cell. So now it's an int. If I change what I made that assignment to, now it's a float. If I change that to hello, now it's a string. And if I change that to true, now it's a bool, right? So we can change the type of a variable just by what we assign to it. We don't have to tell Python, hey, now I need this my var thing to be, a string. We don't have to do that explicitly. And that's actually not true in a lot of programming languages. So for example, if you were writing like a C++ program and you wanted to make a variable named my var and assign it to the value 2, what you would need to do is something like this, right? So in C++, you do have semicolons. So that's why I'm putting them there. So this is what the C++ syntax would look like. All right, so first we have to declare, hey, I'm defining this my var thing and I want it to be an integer. And then we can make an assignment, okay? And if we were to do something like this, define my var to be an int and then make an assignment of 2.0, which is actually a float, we would get an error when our program tried to compile. Okay, so other languages can be very, very, kind of picky about that. And the difference, what we actually call that is these languages would be statically typed. Okay, so in a statically typed language, we have to explicitly define the type of a variable, and then we can make assignments to it, and the program will actually check to make sure that you are making assignments that are correct given the type that you explicitly defined. All right, so you got to define the type, and then when you make an assignment, the program will actually compile, and then it will check and say, hey, no, you said this was going to be an int, but you assigned 2.0 to it. That's a float, so we can't do that. That's not allowed. Python, on the other hand, is what we call dynamically typed, right? So we've got variables. We don't have to specify up front what those variables are going to be, and the type is inferred. Python figures that out based on what we assign to the variable. All right, now there's pros and cons of both approaches. Of course, with the Python, if I just change this to 2, right, it's very, very flexible, right? I can assign whatever, and the type that that variable takes on will be dependent on what I assigned or what I last assigned to that variable. All right, so that's, a little bit easier for people that are new to programming because they don't have to think about, as much syntax. We don't have to think about the requirement of, defining that variable type at the beginning, and so forth. So it can lead, to a little bit of, an easy, user-friendly type of situation. But there's also problems that can arise as well, right? So if my var needs to be an integer, and it should be an integer, in the program that you've kind of designed in your mind. But somehow a floating point number gets assigned to it. In Python, you wouldn't know that, right? Or maybe a string gets assigned to it. That'll kind of pass right under your radar, and it could lead to bugs that are sometimes hard to diagnose. Whereas in a statically typed language, it's going to do that checking and say, this isn't allowed. Again, it can be a little bit extra syntax, a little bit extra, kind of thinking. And it could even lead to situations where you have to have a lot more variables because you got to have different variable names for each of these different situations. But again, it's very good from making sure that your code is doing what you expected or anticipated that it will do. And also the programming language, because you're explicitly telling it what things are, it can do some optimizations, right? So maybe there's certain things, if it's got floating point numbers for a variable, it can do some type of optimization to make a certain thing run faster. Well, in Python, we really can't do that, right? Because at runtime, it doesn't know exactly. You can put anything into that variable. All right. And there are some changes in the Python language where they're looking at, well, can we put some of those optimizations in there anyway? And they've already started that effort and sped up Python significantly in later versions. But, that's kind of the trade-offs with them. All right, so I am going to cut this cell. A few other things about variables. One thing I wanted to show you, so up to this point, we've looked at cases like this, well, x is equal to 2. Right, but you can also do what we call multiple assignment in a single line. So I could do something like this, x, y equals to 3. All right, so now if I were to look at x, that's equal to 2, and y is equal to 3. So on this left-hand side, where I'm doing my variable name, I'm saying, well, define variables x and y, and assign those to 2 and 3. So the ordering is just, respective on each one. So the second element on the left hand gets assigned to the second element on the right hand. And this is, can lead to much more concise code. Personally, I do use this, but if it, usually I'm trying to keep it to assignment of like 3 or less, because if you get this really long assignment where you might have 10 variables on the left-hand side and 10 on the right, of course, to do that assignment, it can be a little bit hard for people to interpret when they're reading, because you got to sit there and kind of think about, well, that's in that position, which variable is that mapping to? So usually with, 2 or 3 at most variables, that's okay. But it is used a lot. And one really, really nice thing about, this ability to do this assignment is it makes one very common operation that we see a lot in programming very simple. And to demonstrate that, I'm just going to recopy this code, bring it down. So I've got x, y is equal to 2, 3, right? We already saw that led to x is equal to 2 and y is equal to 3. Well, what we can actually do is we can swap the values of those variables, which is, again, something that is, a very common task in programming. So I can just say, well, now that I know, well, x is, let me just show that again, x is 2, y is 3, right? Ran that in that same cell. Well, what I can actually do now is say xy equals yx. So just making a reassignment to these values based on what's on the right-hand side. So swapping that, All right, and now we have x is equal to 3 and y is equal to 2. So you can do one-line swaps with this multi-assignment very easily. All right, just a few other things that I wanted to show. So let's just go back and let's just say, well, x is equal to 3 and y is equal to, let's put these on different lines. There we go. So right now I've got a variable x equal to 3, y is equal to 5. The last things that I'm going to show in this video is related to comparison. All right, so let's just look at, first off, we can do the very simple, like kind of greater than, equal to, or equal to. How do we do comparison? So up to this point, we saw that we use a single equal sign when we're doing the assignment to a variable. But if I wanted to compare and say, are two values equal or two variables equal to one another, you use this double equal sign, and that's actually doing a comparison. So it's going to return a Boolean, right? So if I were to wrap that in type, I can see the type of the thing returned. That's a Boolean type. All right, so we have, in this case, we know that x is not equal to y, right? They're 3 and 5. But we could say, well, is x greater than 5? Well, that's false. Is x less than 5? Right? And we could do, of course, the greater than or equal to variance. So we could say, well, is x greater than or equal to 5? X less than or equal to 5. All right, so these are our comparison operators. And then finally, even though I showed you, are the two values equal, we also have a not equals. So you do that with an exclamation point equals y. And there we go. So in this case, it is true that these two values are not equal to one another. The one kind of special case that I will show you is that none operator. So what we can do is we can say, you know, x, you can do x equals none. That will work. All right, so let's just make a variable. Let's make a variable z. Let's set that equal to none. And so if I were to say, well, is z equal to none? And we can say, well, okay, that's true. So it is equal to none. The preferred way to do this, and this is going to kind of open up a little bit of a wormhole that I'm going to kind of go through, and you might not understand this completely at this point, and that's okay, but I do kind of want to show you this as we're talking about these comparisons. The preferred way to do this comparison is z is none. All right. So instead of using this double equals, we can say is none. All right, it says, well, that's true. And you can also check to say, okay, z is not none. That should return false. Why should it return false? Because up here we've actually assigned z is equal to none. Now you might say, well, okay, well now we got this is and this is not, and that seems really equal, very similar to that comparison of the double equal sign, the not equal to. So what's the difference between is and this, you know, equals to comparison, and is not and this not equals to? And this is where it's going to get a little bit challenging, right? So a little bit subtle here. So, but what I'm going to try to, you know, kind of let you see behind the hood here. All right. So the first thing is none, right? In this case, what's going on is none is actually a specifically defined value. It's an object that points to nothing, but Python's got it predefined in its system, and it is, if you define two instances, so if I define x is equal to none and y is equal to none, these two things are actually going to point to the same object on your computer's memory. They're both pointing to the none object that's defined in Python. So it's the same memory address on your machine. And again, this is a little bit challenging, right? So now if I say, you know, x is none, is saying, well, is that object, is x pointing to the same memory address as that none? So is it the actual thing on my computer's memory? So x is none, it's pointing to that. We could also, this works, right? Is it that? But notice what happens here. So if I do x is y, that's true. So in this case, we've got x is equal to y. Of course, that's true. They're both equal to none, but x is y is also going to be true in this case, right? Really kind of subtle and interesting here. All right, so these two things are pointing to the same memory address, okay? Let's just see. So don't try this at home, but let's just see if we can demonstrate this further. So we know, well, in Python we've got these defined words. Let's see if we could overwrite that. Or we won't do this. We will. Yeah, let's give it a shot. Let's just see. So if we've got none here, that's a certain memory address. Let's see what happens if we override it. So we know that we can do that. So it actually, Python is going to prevent us from assigning to none. So that is going to prevent that. I was going to say, since they're pointing to that same address, can we override it? But that apparently is the one case where Python is not going to let us do that. But we'll check some other ones here in a minute. All right, so again, I've kind of opened this can of worms of saying we've got this is operator, and it's because we're pointing to the same memory address. And I want to show you a few additional kind of interesting little special cases that result from that. Okay, so first off, let's just look at some integers. All right, so if I were to do x is equal to 1, notice we got the green text right there, and then y is equal to 1. All right, so now if I were to say, well, is x equal to y? Are they equivalent? Right, that's true. But now if I say x is y, they're also true, okay? So x equal to y, so are they equivalent in their value, or x is y? Okay, so both of those are true. This one's indicating value equivalency, the double equals. This one is indicating they're actually pointing to the same location in memory, which is interesting. So anytime you're using the integer 1 on Python, you're pointing to a specific part on your memory. So Python does this with a certain subset of integers. Right? To see that, let's do that with 256. All right, so I'm going to assign x and y to 256. Does x equal y? Yeah, they're equivalent, right? Is x y? So x is y, that's true, right? So that worked. Watch what happens when I put it to 257. All right, so are they equivalent? Yes. Is x is y? Returns false. So now, for the first 256 integers, the positive integers there, Python was apparently using a predefined spot in its memory allocation to hold those integers. And every time you make an assignment to one of those integers, you just get pointed to that same memory address. And they do this. This is actually a known thing that they the language maintainers do, because those first small integers, apparently up to 256, are used very frequently. So they just go ahead and kind of hard code that memory address. So anytime you make a declaration or assignment to one of those variables, you're pointing to that, right? So we see where that tipping point is, right? So if I go back to 256, we get true, true. So x is equal to y, but x is also just pointing to that same memory address. But as soon as we go to 257 and define those, well, now we're getting two different memory allocations in Python. All right. Let's just maybe show this again another way. So let's see if this works just as a testing point. So let's say that I were to do assign x equal to 1, and then this one equal to 1.0. All right, so is x equal to y? Now, this comparison might actually return false when we run this, right? So right now, this is the last cell that I've ran. Let me just go ahead and clear the output of that. Let's see. Can I clear the output of that one? So I'm just going to go ahead and delete these cells so it's not as confusing. So here's the last cell that I've run. We've got x is equal to 1 and y is equal to 1.0. So this is an integer. This is a floating point representation. And sometimes this may actually return false, because sometimes the way that programming languages represent floating points, there might be just some small difference in a very deep decimal point. So this could return false, but let's just check and see. So in this case, it did not. So it's saying, hey, those two things are actually equivalent. The values are equal. But if we do x is y, they're false. And they have to be false in this case because this is an integer representation of 1 and 1.0 is a floating point representation. All right, so hopefully that makes a little bit of sense there. So again, none is just it's a reserved type or a reserved object, represents nothing. It's got its own memory address, and apparently we can't overwrite that, which is a good thing. We should never overwrite none or any of the other built-ins to Python. And when we were doing these comparisons, we use that double equal sign that compares to say, okay, well, are these things equivalent? Are they the same value? And we can use is to say, are these two things pointing to the same object in memory? Okay. Another time that you will want to use is, and I'm just going to demonstrate, I think we run into the same set of issues here, is with the Boolean type. So I do believe if we were to do true equals 2, I don't think it will allow us to do that. Yeah, so we also can assign to the Boolean, so true and false both have their specific points in memory. So as a result, if you're checking if something is true or false, you would say, well, like my var equals true. And then we'll say, well, my var, instead of double equals true, you'd want to change that to is true. And again, that's going to return a Boolean comparison. So a lot to it. Right? It seemed like a pretty innocuous topic. We were going to talk about defining variables. We've looked at a few additional special cases, talked about dynamic, static typing, looked at this, these comparisons and this whole notion of is and memory addresses. But hopefully that was clear. And again, you're going to get a lot of practice with these if you're writing Python code, writing algorithms. And I'm going to have a lot of videos focusing on those different things. So you should see this a lot if you do choose to watch those videos. But for now, I'm going to stop this one, and we'll see you on the next video.